Still with you. This is Teacher Edson from Good Times Infant School, KAWAALA. Once again, we meet in a mathematics lesson, which we had last time about repeating decimals. And I know you did the activity I left you with. So we are coming back for the next lesson. But I would feel we start with the corrections of the previous work, such that you check what you did. If it is on track, then we go to the next lesson. So I beg you, go to your previous work you did about changing fractions to recurring decimals, or which we call repeating decimals. And if you are there, I left you with 4 numbers, or 5 I think. So let us look at the correction. Number 1 was, the question was, express the following fractions as decimals and identify which fraction is repeating or non-repeating. So number one was a quarter. So if we're expressing this a quarter, when you look at multiples of 4, we don't have any 1. We don't have any 4 in 1. So we have a 0. 0 times 4 gives us 0. We subtract, we get a 1. As we said, you put a decimal point, add a 0. How many 4s can we get from 10? You will see there are 2. So 2 times 4 will give us 8. So when we subtract 10, take away 8, we get 2. We already have a decimal point. We put a 20. We put a 0, it becomes a 20. So how many 4s are in 20? You will tell me 5. And 5 times 4 is equal to 20. So 0, 0. Now this is 1 out of 4 equals 0.25. Please note that here we don't have dots and we are not showing dots because this is a terminating fraction. It has completed. It is not continuous. And the question was saying we identify which fraction is repeating or non-repeating. So this is a non-repeating fraction. So we say a quarter is a non-repeating decimal. Number 2, we're trying to do corrections quickly. Number 2 was 3 out of 11. So 3 out of 11, this is, we are listing multiples of 11, looking for a 3. How many 11s do we get from 3? Of course, there is not any 11. Then we write our 0. This is 0 times 11 will give us 0. So when we subtract, we get 3. What we do, we put a decimal point. We add a 0 to become 30. How many 11s do we get from 30? You tell me 2. So 2 times 11 gives us 22. When we subtract 30 minus 22 by regrouping, this is 2, 10 becomes 8. There is 8. We add a 0, it becomes 80. How many 11s can we get from 80? Give us 7. 7 times 11, this one gives us 77. So when we regroup, we shall get 3. We already had 3, it becomes 30. So our 30 gives us 2, which becomes 2 times 11. This is 22. Minus, this one will give us 2, 10, 8. Add the 0. We already had 8 here, which will give us 7. So which will give us 7 times 11. This is equal to 77. So when we subtract, will be a 3. So you will see that this fraction will continue. It is not like this, where it has ended. So we shall see this fraction will again continue. So we can say we stop here and indicate that it is not ending. So we say 3 out of 11 is equal to 0.27. 2 dots, meaning 2 is recurring, 7 is recurring. But this is not the answer. The question was saying we identify, is it a recurring decimal or not a recurring decimal? So we shall say 3 out of 11 is a repeating decimal. So number 3 was change 1 out of 8. 1 out of 8, this is what we are expressing as a decimal, and see whether it is a recurring or non-recurring. When I put 8 here, this is 1, multiples of 8, you will not find a 1. Therefore, there is no any 8 in 1. So it becomes 0, 0 times 8, this gives us a 0. Now we subtract and get a 1. What do we do there? We put a decimal point and add a 0. So when I put my decimal point here, add a 0. How many 8s are in 10? You tell me 1, 8 is found there. So it will be 1 times 8, which will equal to 8. Now what will I get? 10 take away 8, you get 2. There is a decimal point, add a 0, becomes 20. 8, 16, 8, 16, 24. So we shall take 2 8s, which we are going to get from 20, which gives us 16. Now 20 minus 16, by regrouping, this will be 10, 10 take away 6, will be a 4. Now we put a 0, it becomes 40. 8, 16, 24, 32, 40. So how many 8s are in 40? You will see a 5. So 5 times 8, you will get a 40. So 0, 0. Now this fraction has ended, not like the one which was in number 3. Therefore, 1 out of 8 equals 0.125. What is the answer? The question says identify. Is it a repeating or non-repeating? So we say 1 out of 8 is a non-repeating decimal. When you don't put this answer, it means you have not answered the question. Now let's look at number 4 quickly. I'm a bit too fast because I'm making corrections. You will bear with my speed because we are going to the next lesson. So number 4 was, we change 2 out of 3. 2 out of 3, we are listing now multiples of 3 and a 2. So when you list multiples of 3, 3, 6, there is no 2. So it becomes 0. 0 times 3, this one gives us 0, subtract 2, put a decimal point. Put a decimal point, then we add the 0 here. So we are looking, how many 3s are we going to get from 20? 3, 6, 3, 6, 9, 12, 15, 18. So you're seeing 6. Now 6 times 3 will give us 18. So when we subtract 10 take away 8, we shall get a 2. So a 2 we add a 0, it becomes 20 again. It also gave us 6. 6 times 3 is 18. 20 minus 8, you will see a 2, add a 0, it becomes 20. 20 also here, 20 here has been giving us a 6. So 6 times 3, you will get 18. So when you subtract, you will still get a 2. Now in this, when you compare this fraction and this one ended, but this one, this 2 remains in every answer. So what we say, this fraction is a repeating, or what we call recurring. And now we shall say 2 out of 3 is equal to 0.6 recurring. What is the answer? The answer is 2 out of 3 is a recurring decimal. Then the last one tells us the last question says 5 out of 6. 5 out of 6. Sorry, number 5. So 5 out of 6. Now we are grouping in 6 because we are dividing by 6. Dividing means grouping. So we are dividing in 6 by 6, so we are putting a 5 here. When we group in 6 sort of, we don't have a 5, it becomes a 0. 0 times 6, you get a 0, subtract, you get a 5. Put a decimal point and a 0, it becomes 50. Now we're going to look at how many 6s can we get from 50. 6, 12, 18, 24, 30, 36, 42, 48. So in my hands I have 8 6s. So that means 8 times 6 will give me 48. So when I subtract this one, 4 comes 2. Now I put a 0 here. When I put a 0, it becomes 20. Now how many 6s are in 20? 6, 12, 18. I will have 6. I will have 3 6s, which is 3 times 6, giving me 18. When I subtract, I will get, this is here 10, 2. Now, when I add again, it becomes 20. I remain with 20 here. I'm remaining with again 20. So, of course, that will be again 3, which is 3 times 6. This is also 18. When you subtract, you will also get 2. So, from that thing, you see that these two will remain in our subtraction. So we can stop here and we say 3 is repeating. 8 is not repeating, but 3 is the one repeating. So what do we say? 5 out of 6 equals 0.83. 8 is not recurring, I don't give it a dot. So I put a dot on 3, which means that 3 is recurring. The answer now becomes 5 out of 6 is a repeating decimal. So those are the corrections, and you check with your answers. If they are not like this, kindly please make corrections. So example 1 says change 0.3 to a rational number. 0.3 recurring to a rational number. Now our question is, this rational number means a fraction. So this fraction will come from this. So we let this rational number we want to be any unknown. Let the rational number be k. Now, this rational number will come from our fraction. So we shall say k equals 0.3 recurring. Should you forget to put this dot on top, that one becomes an ordinary fraction, which is 0.3. And the answer will be totally different. So now, this is an equation. And it looks as if it is solved. K equals 0.3. This is always our equation. So we call this one equation 1. It is an equation because it has two sides and they are separated by an equal sign, in which one side there is an unknown. Now, but this 0.3, we want to make it a fraction. So what do? We multiply by 10 to make sure this 3 becomes a whole number. So how can we make 0.3 a whole number? In my simple explanation, 0.3, we make it a whole number by multiplying by 10, such that this one becomes 3 out of 10. Then times 10, you will see that this one will become a 3. So what do we using that idea, so now this equation we have to consider, because it has very many digits, we have to consider which number can we multiply on this one so that it gives us a whole number. Instead of 0.3, we get a whole number from 0.3. We see this has one decimal place, so when it has one decimal place, we multiply by 10. As I explained the other side, therefore we shall say multiply both sides of equation 1 by 10. Why are we using a 10? Because it has one decimal place, and we make this number, this decimal, a whole number by multiplying by 10. So the both sides, so when we multiply 10 here, this is 10 times k is the same as 0.3 recurring means many digits are there, times 10. So what are we going to get? We shall get 10k is the same as 3 point. But we're not going to say 3 and we end there, because in this one we have seen 0.3 times 10 is 3 out of 10, then we get 3. This is a different decimal number. Why? It has many 3's recurring. We decided to put one decimal place, so we can consider another 3, but also recurring. Why 1? Because here we have one decimal place, and here we also maintain one decimal place. When you put 3, it will be another 3 will give us 2 decimal places. Yet here in the equation 1, we have 1 decimal place. Now, this is now another equation. We can also call it equation 2. Now, we come and look at our 2 equations. The first equation is k equals 0.3. Now, the second equation is 10k equals 3.3. Now, what do we do to get the answer we want? We take a difference of the 2. Then we shall say we subtract a smaller equation from a bigger one. Consider k and 10k, which is bigger. So you will see that 10k is bigger than k. So we shall say subtract equation 1 from equation 2. Now this one will be 10k equals 3.3 recurring, and the other one is k equals 0.3. Now we subtract this side and are the same as this side, and we separate everything by an equal sign. So this one will give us 0. This is 3. 10k minus 1k, what do we get? Because this k stands for 1k. So 10k minus 1k, we shall get 9k. Now, that means 9k equals to 3. So we can look at simplifying that equation. So 9k equals 3.0, which is 3. Now what do we do to get k? We divide both sides by 3. By 9 once, by 9 once. So we shall, okay, so both sides by 9. Sorry. Both sides by 9, divide 9, both sides. So we shall remain with k equals 3 out of 9. This is not a reduced fraction, so we have to reduce it. Factors of 3 and 9, we have 1, 3. So the common factor there is 3 and 3. So what do we get when we divide that? 3 divided by 3, 1. 9 divided by 3, 3. And our equation, the fraction becomes a third. This is now the rational number they want. You can end up saying 0.3 recurring is the same as 1 out of 3. This one is not the same as if the question was 0.3 to a fraction. To a fraction, this would be 3 out of 10, and which would remain there. But because this one has this dot train that is repeating, it is totally different from the other one. So please note that one. Thank you. Quickly, there is another method which I feel can help us. However, it is always have its own challenges, but those who will take it, I think they will find it easy. The same question says we express 0.3 as a fraction. So what we do here, we shall look at this fraction is 0.3, that is 3/10. So this is 0.3, which is 3/10. So we identify here two digits. One digit is recurring, which is a 3, and 0 is not recurring. Now, we shall have a difference. Even in our method 1, we subtracted. You saw the subtraction at the stage of 10k and a k. So even here we can have a subtraction. How does it appear? We get this fraction, 3 digits that 3 out of 10, which is 0.3. This is 3/10 in P4, P3. When they say write this one in words, you write 3/10. Now, we subtract the digit which does not repeat. And when you look at here, which digit is not repeating? 0 is not repeating. Minus 0. Why 0? It is not repeating. Minus its place value. Minus its place value. This is one fraction. Minus its place value. What's the place value of 0? This is 1s, because this is 10th. So this is 1s. So that's why we have 10 here. So minus 1. Up we subtract digits, then down we subtract place values. So what you will get? 3 out of 9. And when you simplify 3 out of 9 as we did, you will get a third. As the answer they did what? They wanted. So let us look at example 2. Example 2 says change 0.8333 recurring a decimal, to a rational number. Please, dear candidates, always note the differences in numbers. In this question, we have 8 is not recurring, but 3 is recurring. So which means this is a bit complex, but we have the steps we have to pass through to make sure we can work it out. One of the steps we have to do here is to know that the fraction we want is coming from this fraction. So we say let the fraction, which is rational number, let the fraction, the rational number, I'm using this word because it's what they have used in the question. There are many words. They can say variable fraction, they can say rational number, they can say a common fraction. So let the rational number be y. Now, this y will come from our equation. So y equals 0.83. Now, I've written the other 3 which are not recurring. This is step 1. Step 2, dear candidates, we have to separate these fractions. 0.8 is not recurring. Then 0.08, this 3 recurring. So this one is 1 decimal place. To separate it with a digit which is recurring, which means here we are going to consider this 1 decimal place, and we shall multiply by 10 first. This is already equation 1. So what do we say? Now multiply both sides of equation 1. Multiply both sides of equation 1 by 10. My dear candidates, there is something here you need to understand. These are 2 decimal places. We are not multiplying by 100. Why? 1 digit is not recurring, so we cannot consider them at the same time. So we shall first separate the digit which is not recurring from the digits which are recurring. So we shall get 10y, because I multiplied here 10. And when you multiply here, this 10 will remove one decimal place, it will be 8.3, now 3. 2 decimal places here and 2 decimal places here. Why another 3? There are many 3's because of this recurring. How has this 8 come? A quick look. 0.83 is the same as 3 out of 100, but times 10 I multiplied both sides. So you will see this 10 will go with that, then I will remain with 3 out of 10. So this one brings 1 decimal point, so which becomes 8.3. This is our ordinary way of just dealing with decimal fractions. Now, this one gives us equation 2. Equation 2. Now, remember when we multiplied by 10 here, we did consider this digit, which is recurring. So we have also to consider it now. The 3 is a recurring digit. In example 1, we multiplied by 10 because one digit was recurring. So which means to come and say, we are going now to multiply another 10 to consider a digit which is recurring. So multiply equation 2 now. Multiply equation 2 by 10 to consider the digit which is recurring. So this one becomes 10y equals 0.833. So when you multiply 10 here and multiply 10 here, it will give us another equation. This one we shall get 100y. Now this 10 will take back the decimal point, so it will give us 83.33. I'm bringing another 3 to keep my 2 decimal places, which I had from the start. From here, I have 2 decimal places, 2 decimal places. So when I remove this one, it means that I will remain with 1 3, but I have very many recurring digits, so I can add another 3. Now this is equation 3. This is equation 3. Now we shall now consider 2 equations. This equation 2 and equation 3, and we subtract them. So according to what you see 10y is smaller than 100y. Therefore we shall say subtract. What are we subtracting? Equation 2. Subtract equation 2 from equation 3. We leave out equation 1 because it's not considering what we want. Now this is 100y equals 83.33. Now this is 10y equals 8.33. So when we subtract this side alone and this side alone. So when we subtract this side, 0, 3 take away 3, 0, decimal point, 83 take away 8, because we do it by regrouping. We shall come here and borrow from 8, we remain with the 7, and it becomes 13. 13 take away 3, gives us a 5. Then here, gives us 7. So now, 100 minus 10, this is a 0, this is a 0. Now 10 minus 1, you will get a 9. So 90y equals that. Now we have to solve now the equation quickly. This is 90 equals 75.00. We leave that out of 90. This 90 by 1, 90 divided by 90, 1. So this side remains with y. Now we look at factors that divide 75 and 90. There are many, but we can use 5 first, or we can use any other, but let us take 5. By 5, when we divide by 5 and divide by 5, this one will give us 25, and down will give us, this one will give us 1, remainder 4 becomes 40, so it becomes 18. This is not a simplified fraction. Here it is, no, here it is 1, sorry. Here it is 7 divided by 5 is 1, remainder 2. So it becomes 15 out of 18. Now this is not a simplified fraction because we still have a common factor in 15 and 18, which is 3. So divide by 3, divide by 3. So what is 15 divided by 3? I think the answer you have 5. What is 18 divided by 3? The answer you have 6. Now, which means the fraction they wanted, or the rational they wanted is this. And we saw the first one is 0.8, therefore 0.8333 is the same as 5 out of 6. I've told you a rational number is a fractional term. So that is our answer that you wanted. So still quickly to our easiest method. I call it easiest because it is quick, only it has problems in explanation. The question, the number was to express 0.83. Now this is recurring, 3 is recurring. So this is 83 hundredths. So this is 83 out of 100, 83 hundredths. 83 hundredths. So this is 83 out of 100 as the whole number. But you see this number has 2 parts. 0.8 is not recurring. So which means it is 0.83 now minus 0.8. But 0.8 is 8 tenths. So what does that one mean? You subtract the digit which is not repeating. This is 0 and 8. But we take the last digit. So 0, 8, it will be 8. Now what is the place value? Here we have ones and tens. So we shall consider the last place value here, which is 10. So the place value of the digit we have subtracted here is tenth. 0.8 is 8 out of 10. This is one fraction. So when we subtract from our previous subtraction, you will get 70. You will get 75 out of 90. And when you simplify this by 5, this one will be 15. By 5 will be 18, which will give us 15 out of 18. By 5, 3. By 5, 6. So what will it give us? 3, no, by 5, 3, by 5, no, by 3, 5, sorry, by 3, 5, then by 3, 6, so which will give us 5 out of 6. Example 3, and I hope this is the last one. With this example you have understood. It says change 0.2727 as a common fraction. 0.2727 recurring as a common fraction. So here they have changed the other term which they have been using, a rational number, and now they have brought in a common fraction. Please note, a rational number means a fraction. A common fraction means a fraction in simplest form. So we shall now let this common fraction be k, let the fraction be k. So let it be k. I have considered it to have a common fraction. From English, you can use many words to replace one word. So this k will come from this fraction. This is k equals 0.2727 recurring. This is our equation 1. Now note, in example 2, we had 2 digits, 8 and 3, but 8 was not recurring, while 3 was recurring. But here, 2 is recurring and 7 is recurring. So we're not going to say multiply by 10, separate 2 from 7. No, the 2 are recurring. So from this one we have 2 decimal places. This question has 2 decimal places. Why neglect this? They are the same. Now, when we have 2 decimal places, what do we do to make that number a whole number? We multiply by 100. So we shall say then, multiply 100, multiply 100, multiply 100, both sides of the equation 1. So when you multiply 100 here, you will get 100k. When you multiply 100 here, you will get 27.27, because the 100 will, the 10 will bring a decimal point here, the 110 will bring a decimal point here, and another 10 will bring a decimal point there. But remember, here we have, in our original question, there are 4 decimal places, and we know very well that there are many 2727, so we can keep our decimal places as they are. Now this one gives us equation 2. Now here we take a difference of the 2 equations. This is smaller than this, so we say subtract. Subtract equation 1 from 2. So this one will give us 100k, giving us 27.2727. Now we are subtracting there, k equals 0.2727. So we subtract this side along, 0, 0, 2 minus 7, take away 7, 0, 2 take away 2, 0, decimal point, 7 take away 0, 7, then 2, equals, now 100 minus 1k, this k means 1k, 100 minus k, that would be 99k. Therefore, 99k equals 27. Divide both sides by 99, by 99. 99 divided by 99, 1. 99 divided by 99, 1. Now we shall have k equals 27 out of 99. We cannot leave the fraction here because they say that common fraction. We leave it in simplest form. So factors of 27 and 99, there are many, but I would like to take 9. So when I divide by 9 here, and I divide by 9 here, 9, 18, 27, there are 3, then 99 divided by 9, you will see 11. Therefore, this is our simplified fraction because 3 is the prime number, 11 is the prime number, so the fraction remains there. Therefore, 0.2727, which is recurring, is equal to or equals 3 out of 11 as the fraction they wanted. So, quickly looking at our method 2, because I want us to compare the 2 methods and see can they give us any answer, any method, as long as different methods give us the same answer and does not affect any mathematical rule, is considered to be a correct method. So if there are different numbers but using different methods and giving us the same answer, it becomes correct. Now 0.2727 recurring. This is 0.27 original. So it will be 0.27 recurring. This is 2700. Consider the last place value. Don't consider this, consider the place value. Minus the digit which is not repeating. Minus the digit which is not repeating. Which digit is not repeating here? Is it 7? 7 is repeating. Is it 2? 2 is repeating. Is it 0? 0 is not repeating. Therefore, minus 0. Now, down, we shall subtract the place value of this 0. What is the place value of 0? This is 1s, 10th, 100th. So the place value of 1 of 0 is 1s, and 1s in figures is 1. Now when we take our difference, we shall get 27 out of 100 minus 1 is 99. Now when you divide by 9 here and 9 here, the answer will give you 3 out of 11. When you divide by 9, divide by 9. So you see the same answer using two methods. Thank you. Now let's look at the activity after seeing all these examples.